Hi, and welcome to the Maths Junior Cert Higher Level. We're just starting the paper 2 of 2018, and this is question 1. So as always, as you're working your way through this, if you want the set of notes I'm working off, please send me an email at shanetroy@gmail.com. And as I said, just pause, try the question, and then you can flick on to the answer on the next page. So let's get stuck in here. So for question 1, the part A and B are marked together in the space here. I've kind of edited this from the screen print from the exam paper just to show the space. It's a 10C, so a chance to pick up some marks here. Now the diagram below shows a circle with center O. The 5 points A, B, C, D, and E are on the circle. So A, B, C, D, and E. The length of AB, or rather AB and D, are diameters of the circle. So we're talking there about AB there, the diameter, and so is DE. Okay. And the angle BOE, so the angle at O is what matters, okay, equals 40 degrees. Okay, so BOE there is marked as 40 degrees. So we're looking here, the angles X, Y, and Z are what are labeled here. So X, Y, and Z, and I guess we'll have to find them. Now, as you're looking through it, before you even look at the problems at all, let's see, can we figure anything out? Okay, so we have an angle of 40 here. That means straight line theorem says that should be 180. Take away 40 leaves that at 140 degrees. Okay, so let's write that in there. Okay, now if you keep going with the straight line theorem, 140 and whatever gives 180. So that should be 40. I could have came to that conclusion as well by opposite angles, 40 and 40. Anything else? Okay. What I notice here, there's two. This is the radius here, and that's the radius. So that would make a triangle like that, and both sides are equal length. So it's isosceles, which means both these angles are equal length. I think that's something that will be coming up on later on. Okay, they're equal. So always remember with triangles or shapes, the size of the angle and the length of the side are directly related. Okay. Now I think I've got a fairly good handle on what's going on here. So let's see if we can tackle part A, which says write down the size of the angle X. Now if you get this right and don't get B, you'll get the low partial. Okay. So well, we already have identified it. So your X there equals 40. Okay, and put the units in and the units degrees. So the part B then says work out the size of the angle Y. Now we've kind of cluttered our diagram a little bit. So I might just, for simplicity, just take them away. Okay, and we're looking here now. We know that's 40, so put the 40 back in. As we said, this length and this length are the same. Which means that this Y is the same size as this angle. So we can call that Y. So we know X is 40. We know these angles are the same. Okay, so I just go to the answer here and come up with the statement 180 equals the X plus 2 times the Y. There's 2 Y's. Now we can fit in our numbers that we know, information. Okay, there's 2 unknowns here. We can't solve that. But if we have more information, the 40 from part A, we can see that we have an equation of 1 unknown. Now you may not need me to go through all these different steps here, especially since this is an honours higher level or honours paper. But for those who might be insecure about their algebra, let's go through it. Okay, so we look in here, we want the unknown on one side, and everything else needs to start moving across the far side, across the equal. So I usually phrase it like this: when something goes across the equal, it changes operator. Okay, it's a good rule to go by. So the 40 here is being added on the right, and it goes across to the left on the far side. It does the opposite. The opposite of addition is subtraction. Okay, so do that little sum. 180 take 40 is 140. Now we look, okay, I still want Y on one side. Everything has to move across. So the 2 is getting in the way of that. What is the 2 doing there? What's the operator? It's multiplying 2 times Y. Bring the 2 across the equal, it changes to the opposite of operator. The opposite of multiplication is division. Now, notice it doesn't change sign there. Okay, it doesn't change to a minus going across the equal because the operator was multiplication originally. So we end up with a sum there, 140 divided by 2, which is the same thing as 70. So your Y value is 70, and you can fill it in the diagram or just move on. Okay, so that's part A and B together. Now, if you got part B right, okay, and didn't get part A, you'd have got the high partial of 7. And I suppose something, let's say for some reason you had a fair idea how to do part B, but just couldn't do part A. Just declare any answer. Now, as a good answer, just a guessing answer, like 40-40, why not go with it? And then use that answer, even if it was 30 you picked and you were wrong, the answer you use in part B will be accepted as correct, and you won't incur a penalty in part B. Let's see, now if part B is correct. So the last part here says, work out the size of the angle Z, or Z. Now, there's a lot going on in this diagram, that's why I've copied it across here. Okay, just to try to explain what's going on. We're looking for, obviously, this angle here. Okay, now, you have different shapes going here with triangle, okay, sector, whatever. But there's a cyclic quadrilateral. Don't say that without your morning coffee. Okay, in that shape there, between the points C, D, A, and B. Now, a cyclic quadrilateral, okay, the two angles opposite or angles opposite should add to 180. Okay, we know that Y is 70. Okay, 70 from 180, that should be 110. And that's one way of approaching it. Okay. The other way would be to go the angle in a circle theorem. I think that's the right name. I actually have it on the next page. Okay. There's the answers. Okay. But the one I'm doing now is just this top one. So the angle here would always be twice the angle on the outside of the circle. Now, this particular shape here, we're basically talking about this outside shape here, BOD. Now if I fill it in, if I can, without being too messy, that's the angle we're talking about. That's twice the angle here. Now, the angle there is 40 and 40, and the difference in between is, what was it, 140. So 40 plus 140 plus 40 gives me 80, and 240 is, or 140 is 220, isn't it? Okay. So our angle, our reflex angle, big one here, said 40, 40, and 140, and that gives me my 220. So that's going to be twice the angle up here. So half of 220 is 110. Now, either way is perfectly valid. Okay, I'm sure there's other ways to do it, maybe. They're just the two that came to my mind. Either one is perfectly valid. Now, it's a 5 marker. Okay, so it's not a huge amount of marks, but like if you know your theorems, and those two will be some of the harder theorems, you may not need to know how to prove it as such, but know when to apply it. And these will be two that will commonly be asked at like honours level, so the kind of ones you maybe should focus on. So that's part C. Yeah, that's question 1 done. Okay. So again, I've advised to go back over this question, just try and do it yourself. Once you make a click, something in geometry, that trick will stay with you. Okay, so making that jump yourself, it will be much more memorable than listening to me make that jump. Okay, especially when I have the privilege of having access to the marking scheme. So these kind of questions, if you get, I suppose, good at them, okay, they become very reliable and to some extent satisfying. Okay, so if you're stuck on any of them, it's worth watching maybe a video on those theorems, and you make use of Google and Google Images. You'll often find a great way of representing that. That's why I've thrown in 2 images there, just to hopefully get across that point. Anyway, best of luck now, and see you on question 2. Thank you.